Okay, so on this problem we're given the function f of x equals x squared minus 2x minus 3, and it says determine graphically any relative maxima or minima, so we're looking for hills or the y values in the hills or valleys, and intervals over which the function's increasing or decreasing. So the first thing we need to do let me clear that out and see if our batteries will last long enough. And we're going to hit zoom 6 to get our standard window. We already have a function in there that I don't want, so I'm just going to hit y equals and clear it out. And let's put in our function. X squared minus 2x minus 3. And we're going to graph it. Okay, so we have a function. Obviously we were expecting this to be a parabola. And when I ask my students to put a graph on a test for me to show me, I like to see several things. I like to see the intercepts, and for certain I want to see the vertex. Well, in this particular problem, if I hit the trace key, the first thing I see is that the y-intercept is the ordered pair 0, negative 3. So I'm going to put that on my graph paper. Okay. I can also see that the x-intercepts are negative 1 and positive 3. So positive 3, negative 1. And my vertex, since I've hit trace already, let's just sort of go to the very bottom of the valley and see what we're coming up with there. And it looks to me roughly, unless you're told otherwise, I want the vertex to be nice and pretty with integers. So in this case it looks to me like our vertex is at the ordered pair 1, negative 4. So 1, negative 4 is my vertex. And we got there by tracing to it. Another way I've taught you in class to get there is by using the max or min function from the calculate menu. And of course another way to get there is to go to table, and when I look at the ordered pairs in the table, I can see that the ordered pair 1, negative 4 is the lowest. So you have a number of ways to get there. Okay? Now, this is our graph. I want to know the relative maximum. I want to know the relative minimum. And I want to know where the graph is increasing and where the graph is decreasing. So, to find the relative maximum, I'm trying to look at the top of a hill, right? Well, there's no hills here. So for relative maximum, we're just going to say none. There aren't any. When I'm trying to find the relative minimum, I'm looking for the y value at the bottom of the valley. And this is my vertex. Vertex was the ordered pair 1, negative 4. Okay? So my relative minimum is going to be the y value here, which is in the valley, and that would be negative 4. Remember, a minimum value is the y value, it's not the ordered pair. Okay, where is a function increasing or decreasing? Well, let's draw this line in where x equals 1, because what's happening to the left and right of that line is where the graph is changing what it's doing. Here, the graph is decreasing, and on this side of the line the graph is increasing. And remember, we always use the x value to determine where a graph is increasing or decreasing. That's how we always give the answer. So if I want to know where a graph is decreasing, I'm coming on the x-axis from negative infinity to the x value of 1. So decreasing will be going from negative infinity to 1. And again, remember, with increasing and decreasing, you never put a bracket. It's always an open interval. Increasing, I start at 1, and I walk out on the x-axis toward the direction, just, keep walking. So that's the symbol infinity. So the way I would answer increasing is from x equals 1, not included, 1 to infinity. And we're done.